Hi everyone, today we're going to be doing section 10.3. It is going to be about inscribed angles and tangents. So let's start with inscribed angles. An inscribed angle is an angle with its vertex on the circle and its sides are chords. So for example, if you're looking at this picture, this is an inscribed angle right here. So in other words, angle QRS is an example of an inscribed angle. Its vertex is right on the circle. It's not at the center of the circle like central angles, it's on the circle. Next, let's talk about an intercepted arc. So as we talked about a minute ago, we have in this picture an inscribed angle. Here is the inscribed angle. Well, this arc that it opens up to right here between Q and S, that is the intercepted arc. So an example of an intercepted arc in this case would be arc QS. Remember, for arcs, we put that little arc symbol above it. So we have an inscribed angle and we have an intercepted arc. And one more thing. If the angle is inscribed in a circle, then the measure of that angle equals 1/2 the measure of the intercepted arc. In other words, this angle down here in the second picture, angle 1, is going to be half of whatever this arc AB is. So we can write the measure of angle 1 equals the measure of arc AB divided in half, or half as big. In other words, if this arc is 100 degrees, this angle will be 50 degrees. This is different than when we studied central angles. So just off to the side here, I'll just remind you, if you have a central angle, it's going to have its vertex right at the center of a circle. If this is 100 degrees on the arc, this angle would also be 100 degrees. The central angle is the same as the arc. However, if you have an inscribed angle that opens up to that same arc, it's going to be half as much. So this angle down here would be 50, this angle right here would be 100. Let's try an example. Let's start by finding the measure of angle P, number 1. Angle P is this angle right here. Notice the angle opens up to this 70-degree arc. Here it is. And it opens up to that 70-degree arc. Well, the inscribed angle should be half of the arc. So we just take 70, divide by 2, and we get 35 degrees, and that is the measure of angle P. Second question, find the measure of arc PQ. I think there's a little typo on this page. Please make that O into a Q. Otherwise it doesn't make sense here. But we want to find the measure of arc PQ. So we want to figure out how many degrees is that arc. Not the arc length, but the arc measure. Well, notice this angle, the 56-degree angle. That 56-degree angle opens up to arc PQ. The intercepted arc should be double of the inscribed angle. The angle is half of the arc. So if we take 56 times 2, we get 112 degrees, and that would be the measure of arc PQ. Please pause the video and try numbers 3 and 4 on your own. So for number 3, to find the measure of angle C, you can see that angle C opens up to this arc, which is 98 degrees. So angle C should be half of 98. 98 divided by 2 is 49 degrees. For arc CF is right out here. I just outlined it in green. Notice this angle, the 40-degree angle, opens up to that arc that we're looking for. The inscribed angle is half of the arc, so if we take 40 times 2, we get 80 degrees for the measure of arc CF. Next theorem. If two inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. Let me show you what I mean. Let's start by drawing an inscribed angle in this circle. So everybody go ahead and draw in an inscribed angle, and let's put a 1 inside of there. This can be our inscribed angle number 1. Notice its vertex is right on the circle. Okay, now let's draw a second inscribed angle, but we want it to open up to the same arc. So here it is, and that I will call angle 2. So go ahead and draw in angle 2. Both angles 1 and 2 are inscribed angles, and they both open up to the same arc. Now, since they both open up to that same arc, angle 1 must be congruent to angle 2. Think about it. If this angle out here was 100 degrees, angle 1 would have to be half of 100, and angle 2 would also have to be half of 100. So whatever that arc is, they both have to be half of it, therefore they must be congruent to each other. So if we go down to number 5, you can see it says find the measure of angle T. Well, angle T is this angle right here. I can see that it opens up to arc SV. Well, on the other hand, angle U also opens up to arc SV. They both open up to the same arc. I don't know how big they are, but I do know they have to be congruent to each other. They both have to be half of whatever that arc is. So what I can say is 3x minus 5 must be equal to the 2x plus 15. And now I can solve it for x. So go ahead and do that. And we get x equals 20. However, that is not our final answer. Notice what they're asking for. They want the measure of angle T. So we need to take the 20 and we need to plug it in for the x in angle T. So the measure of angle T is going to be 3 times 20 minus 5, which is 60 minus 5, which is 55. It's an angle measure, so we will say degrees, 55 degrees. So this is a pretty cool one. It says an inscribed angle of a triangle intercepts a diameter or a semicircle if and only if the angle is a right angle. Okay, let's take a look at this picture. Everybody look at angle G. Angle G is the important angle here. Angle G opens up to a half circle. Half of a circle is 180 degrees. However, G is an inscribed angle. G has to be half of 180, and 180 divided by 2 is 90. So if you look at that again, that triangle that you see right here has to be a right triangle. So a couple of things. Number one, FH, segment FH is a diameter. It goes across the circle through the center of the circle. Number two, the measure of angle G ends up being 90 degrees. Why is that important? Go down to number 6. So number 6, it says, find the measure of angle F. Well, we don't really know how big angle F is. I can see that, it opens up to an arc over here. I can see it opens up to this arc, but I don't really know how big that arc is. So that's not super helpful. But what is helpful is if I look closely at angle G. So angle G opens up to a diameter FH or a semicircle. Remember, half of a circle is 180. Angle G is an inscribed angle. It has to be half of 180. It has to be 90. So what happens is we get this triangle in here. That would be a right triangle. And I know something about all triangles. The angles in every triangle have a sum of 180 degrees. So if I add all 3 corners together, it should equal 180. So I'm going to do 4x plus 2 plus 9x minus 3 plus the 90, which is right here. I have to add all 3 corners. If I add them all together, I should get 180. Combine your like terms. You have 13x, and then you have, let's see here, so it would be 87 plus 2, so 89. Subtract your 89. I believe you get 91. And divide, and I think it goes in there nicely. Yep, x goes in there 7 times, or 13 goes into 91 7 times. That is not our final answer, though. Our final question says find the measure of angle F. So we're going to need to take this 7 and plug it in. So we're going to take it and plug it into angle F. So the measure of angle F is going to be 4 times 7 plus 2. which is 28 plus 2, which is 30 degrees. And that is our final answer. Next, instead of a triangle being inscribed in a circle, let's talk about what happens if we have a quadrilateral inscribed in a circle. So here we have a quadrilateral, it's inscribed in the circle. You can see that its four corners touch the circle exactly along the circumference there. And what this theorem says is if the quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Let's think about angles L and N. They would be opposite angles. They're not right next to each other. They're not adjacent. So angle L is right here. Notice angle L opens up to this arc. So this angle opens up to this arc. So whatever that arc is, angle L is half of it. Well, now think about angle N. Angle N opens up to the rest of the circle over here. And so whatever that arc between K, L, and M is, this black arc, whatever that is, this angle, angle N, will be half of it. Well, between the two arcs, we have the whole circle, which is 360 degrees, which means the angles have to be half of the 360 degrees. In other words, they have to be supplementary. So the measure of angle K, let's say the measure of angle L plus the measure of angle N must equal 180 degrees. The same also goes for K and M, so the measure of angle K plus the measure of angle M must also equal 180 degrees. So a quick summary, if you have a circle, if you have a quadrilateral inside the circle, if you know one angle is 80 degrees, then the one across from it would be 100. They have to be supplementary. The opposite angles have to add up to 180. Let's do number 7. It says find the measure of angle A and the measure of angle B. All right, starting with angle A, I can see that this lovely yellow jewel in here is a quadrilateral. And so opposite angles should be supplementary. I can see that at angle C, there's a little 90-degree mark in that corner. And so if I want to find the measure of angle A, I'm going to take 180 minus 90, which is going to be 90 degrees. So the measure of angle A is 90. Angles B and D also have to be supplementary because they are also opposite angles. So this angle and this angle are opposite angles in a quadrilateral that is inscribed in a circle, so they should be supplementary. So if I add them together, they have to equal 180. So 2x minus 30 plus x equal 180. This angle plus this angle equal 180. Combine your like terms. So we have 3x minus 30 equals 180. Add your 30. So we have 3x equals, what is that, 210? X equals 70. That is not our final answer. We need the measure of angle B. And so to find that, we're going to take our 70 and plug it in. So I'll just move my work up top here. The measure of angle B is going to be 2 times 70 minus 30, which is 110 degrees. Go ahead and pause the video and try number 8 on your own. All right, let's say you're finding the measure of angle X. So the 60 and the X are opposite of each other. We have a quadrilateral inscribed in a circle, so they should add up to 180. So to find the measure of angle X, we are going to do 180 minus 60, which is 120 degrees. To find the measure of angle Y, we're going to take 180 and we're going to minus the 95 because the Y and the 95 are opposite angles in that quadrilateral. That ends up being 85 degrees for the measure of angle Y. Number 9, find the measure of angle RTP. Now, if you look closely, angle RTP is just a little tiny sliver of an angle. It's this little angle right in there. angle R to T to P. In order to find that, we're going to use a couple of things that we've learned. So first, I want you to notice that what we have is an isosceles triangle. This is a radius and this is a radius. And they would be the same length because they both start at P, the center, and go towards the edge of the circle. Which means that this triangle right in here is an isosceles triangle. And if you have two sides that are the same, you're going to have two angles that are the same. So this angle will be 30 degrees right down in this corner. A second thing I want you to notice is this 70-degree arc. This angle, angle RTS, opens up to that 70-degree arc. It is an inscribed angle and should be half of the arc. So this would be 35 degrees. What we need is the little sliver of difference between these two. So we're going to take 35 minus 30, and we have 5 degrees left, which is going to be the measure of that tiny little sliver of an angle, angle RTP. When you think of the word tangent, you might think of some of its other definitions. For instance, we just got done learning about sine, cosine, and tangent. So it was one of the trigonometric functions. Or you might have a teacher that goes off on a tangent, which means they talk about something that's really off topic. Today we're going to learn a third definition of tangent, and that definition is it's a line that intersects a circle in exactly one point. So technically the mathematical definition is a line in the same plane as a circle that intersects the circle in exactly one point. We're just going to write this. A line that intersects a circle in exactly 1 point. So you can see in the picture that the red line, line AB, is a tangent to the circle. So an example of a tangent would be line AB. Remember, to name a line, you'd have to put the double arrow above it. That is a tangent to the circle. It just skims past it and touches it in 1 point. Now the point of tangency in this case is A, and the point of tangency is the point where a tangent intersects a circle. So in this case, the point of tangency is A. And if you look at the pictures below, you can see that sometimes you'll have two circles that have a common tangent. So in this case, in this first picture, line L touches both circles. It touches circle F in 1 point. It touches circle G in 1 point. And so it's a tangent to both circles. In other words, it's a common tangent. Same with line L in this other set of circles. It touches circle F in exactly 1 point and circle G in exactly 1 point. So it's also a common tangent. So here's something kind of cool. In a plane, a line is tangent to a circle if and only if it is perpendicular to a radius drawn to that point of tangency. In other words, if you look at this picture over here, line L will be a tangent to the circle if it is perpendicular to segment ST. Let me show you what I mean by doing example number 10. So it says, is segment KL tangent to circle J? Well, if it is tangent, this corner down here would be 90 degrees. So we're going to try to figure out, is that a right angle? Now, in order to figure out if that is a right angle or not, we can use the Pythagorean theorem. And so we want to do a squared plus b squared equals c squared. But one thing is a little bit tricky here. See this radius of 8? This radius will also be 8. And so this whole side from K to J is actually 17. So when we do this Pythagorean theorem, we're going to do 8 squared plus 15 squared, and we're going to see how does that compare to 17 squared. We're going to try to determine if they're equal, if it balances out. If they do, then it's a right triangle. So 8 squared is 64, 15 squared is 225. If we add that together, we get 289. Well, it turns out 17 squared is also 289. So because the two sides of the equation balanced, then yes, we know that this would have to be a right triangle. And so this corner right here would be a right angle, and therefore, yes, segment KL is a tangent to the circle. So the answer is yes, because the Pythagorean theorem balanced out. Now notice that trick about how each of these had to be 8. You might have to do that on a test or a quiz in the future. But notice how number 11 is different. Even though we can see that this radius right here is 6, we don't really need to take that into consideration because of how this 12 is drawn. So if I want to figure out if GH is a tangent, again, I'm going to try the Pythagorean theorem. I'm going to try to figure out, is this corner a 90-degree corner? So I want to do 6 squared plus 8 squared, and I want to see, does that balance out with 12 squared? Well, this is 36 plus 64, which is 100. But 12 squared is 144. They are not equal to each other. Therefore, no, segment GH is not a tangent to the circle. So no. All right, last question, number 12. Find the value of x. Assume that the segments that appear to be tangent are tangent. What they're telling us this time is, yes, go ahead and assume that that is perpendicular. Assume that JH is a tangent to the circle. And so we're going to do Pythagorean theorem again. And so I can see the two legs are x and 12. So I'm going to start out x squared plus 12 squared. But that third side, the hypotenuse, that's the tricky side. That's going to be x plus 8 squared. You have to add those two together to get the length of the hypotenuse. So we have x squared, 12 squared is 144, and the tricky part is x plus 8 squared. We have to divide that into two binomials, and we're going to multiply x plus 8 times x plus 8. So what do we really have to do here? We have to FOIL, or box method. You guys have done this a lot in algebra and a little bit in geometry. So let's see if we can remember how to do that. So I'm just going to leave this side, x squared plus 144. When I FOIL, I'm going to multiply the firsts. So the first in each parenthesis, x times x, is x squared. Then I'm going to do the O. The O means the outsides. That's going to be the x and the 8. If I multiply x and 8, I get 8x. Then I'm going to do the insides, which the insides are going to be the 8 and the x on the insides. So that's 8x. And then I'm going to do the lasts, which is going to be the 8 and the 8, the last thing in each parenthesis, which is 64. Now, if you do the box method, you should get those same four terms. Start combining your like terms. So we're going to have x squared plus 144. Over here, we're going to have x squared plus 16x plus 64. Remember, our goal is to solve this for x. So my next thought was, okay, I'm going to try to get this x squared over by the other x squared. What happens is they cancel, which is going to actually make our life easier. So we wind up with 144 equals 16x plus 64. Those x squareds both canceled out. Continue to get your like terms together. So I'm going to minus this 64 and bring it over by the rest. I believe that is 80. So we have 80 equals 16x, and then divide by 16. And I think it goes in there a nice 5 times. So x is 5. Pretty cool. All right, you guys, it's time to try the 10-3 homework. Please don't hesitate to ask for help if you need it. Have a good day.